All right, I want to use these last two examples, the simple interest example and the commissions example, and I want to connect to maybe some traditional methods that you've learned in the past, not to promote them, but just to connect them to what you may already have understood. Let me tell you what I mean. All right, so in this case, with the simple interest, sometimes, let me get a different color here so you can distinguish. Sometimes students have learned that 3.75%, and to convert a percent to a decimal, you move the decimal two places to the left, or you move the decimal two places to the right. And I'm saying it that way because sometimes students, it's like a flip a coin. Do you move the decimal to the left? Do you move the decimal to the right? What I want to talk about is, why do we move the decimal at all? Let's talk about that. So let's look back at the work here. The work that we did is, first, because all 100% was $250,000, $25,000 in this investment case, we first split the 250, why do I keep saying that? We split the $25,000 up into the 100 individual squares. So that was our first move. And then, since it was a 3.75%, we needed 3.75 of the squares. Our next move was to say, well, how much would 3.75 times that amount be? So I want to just rewrite that a different way. So we first divided by 100, then multiplied by 3.75. But couldn't you likewise have done this? Let me write it out. So we took $25,000, first split it up into the 100 squares, and then multiplied by 3.75 of the squares. Couldn't you equivalently say 3.75 divided by 100 times 25,000? You're supposed to say yes, that you can do that equivalently, but what I want you to connect to is this. What happens when you take 3.75 divided by 100? Well, if you need to do it, 3.75 divided by 100 is 0.0375. Ah, that's the moving the decimal two places to the left. Maybe you've seen it this way. You go doink, doink. You move the decimal two places to the left. That's the moving two decimals to the left. 3.75%. Look at that. 3.75 per 100. That's what percent means. 3.75 per 100 is the same as 0.0375. It's moving the decimal two places to the left. And then we multiply that by $25,000. Since the interest is 3.75%, 0.0375. And when you multiply those together, you get the same thing we had before. You get the $937.50. $937.50. So here we did thinking based on our tool of 100 squares. We wanted to figure out how much money was in each square. I have 3.75 of those squares, so I was able to figure it out. But the traditional algorithm would be something like this. First, take 3.75% and convert it to a decimal, and then multiply by the $25,000, you get the same thing. So if you want, if you want to drive students towards the formula, towards the thing, oh, by the way, the formula, we then took 937.50 cents and did 5 years of it. Now the formula was the interest you earn is the principal times the rate times the time. It's PRT. And so if you look back here, that's exactly what we did. We took the rate times the principal, and then we did that for 5 years. My argument is, let students figure that out. We don't have to start with the formula and then just turn it into a plug and chug. We start with meaning. What does percent mean? And turn it into a thinking and reasoning exercise. But for you all as future teachers, I wanted to connect it. I hope this does. I wanted you to connect it to interest is P times R times T. There's the formula, but it all makes sense when you follow your nose, follow the work. Hey, what about the commission? Do you see it there? In the commission case, Ron sells $125,000 and he makes 4.5% commission. Now, again, the traditional approach might be, hey kids, 4.5%. First, move the decimal 2 places. Well, which way, they don't always know, but move the decimal 2 places would be a thing, and then multiply by the amount. Well, let's look back and see what we did. We first did 125,000 divided by 100 to see how much money would be in each square. And then we knew we had 4.5 squares, so we multiplied by 4.5. But watch this. See if you can see the moving the decimal thing. So we took $125,000 and first divided it by 100 to see how much was in each square. And then we multiplied by 4.5 squares. But can you see it? It's the same thing as taking 4.5 dividing by 100 and then multiplying by the 125,000. It's the same thing. Now, 4.5 divided by 100. 4.5 per 100. 4.5%. There it is. There's the 4.5%. And dividing by 100 would give you 0.045. There's the moving the decimal thing that maybe you remember from school. You would have moved it to the left if you'd remembered that. But again, I'm not even trying to get to that idea. We're not moving the decimal. That's not really a mathematical thing to just move the decimal. What's really happening mathematically is you're dividing by 100. And why are you dividing by 100? Because it's a percent. And because you wanted to know what was in 1%, what we did is we took the $125,000 and divided by 100 to see what was in 1%. But equivalently, you could have said 4.5 per 100, 4.5% is 0.045, and then multiply by the $125,000 that Ron sold in total sales, and his commission would have been that, what was it, 56.25. All right, now again, somebody might have said a formula. Your commission is your rate of commission as a decimal times the amount of sales or something. Maybe there's a formula for it, but I don't think the formula helps. I think the thinking is what helps. And then eventually kids might get to the point where, hey, I'm just going to simplify this because I've done this so many times, repeated reasoning, looking for structure. I've done all the standards of mathematical practices, and I can get this to be an efficient thing. But it all comes from student thinking, it's not starting with the algorithm, it's ending with the algorithm using good mathematical thinking. Hope that helps.